To multiply, we just multiply the same as we normally would. So negative 5 times 3 is negative 15. Negative 5 times negative 2i is positive 10i. Letter E, we have 2 times 3 is 6. 2 times 3i is 6i minus 12i minus 12i squared. So we have 6i minus 12i is negative 6i minus 12. And then from the definition up here, we can see that I squared is equal to negative 1. So anywhere that we see an I squared, that's going to be equal to negative 1. So I'm going to write negative 1 here. Negative negative is positive. 6 plus 12 is 18 minus 6i. 4 times 4 is 16. 4 times negative 5 is negative 20i plus 20i minus 25i squared. Notice here that these are going to become 0. So we get 16 minus 25. Instead of I squared, I can replace it with a negative 1. So we end up with negative, and negative is positive 25 equal to 41. Okay. In standard form, this would be 41 plus 0i. Notice that your I imaginary parts here, this became 0. And that's going to happen if you notice our two complex numbers, they look the same with the exception of one is positive or one is being added and one is being subtracted. So when we have the same real parts and the same imaginary parts with opposite signs, then these are called conjugates. And in conjugates, those middle terms will always become 0. And so what that means is, for example, if I had 2 plus 3i, then the conjugate is going to look the same, except I'm going to be subtracting. Since the middle terms cancel like this, then to get our answer, notice here that we squared the 4, gave me 16, and the square for 5 was 25. And so we could do the same thing. The square for 2 is 4, and the square for 3 is 9. So this is going to become 13. Well, you can see that if I multiply 2 times 2 is 4, 2 times negative 3 is negative 6i, 3 times 2 is positive 6i, 3i times negative 3 is negative 9i squared. The 6i and negative 6i cancel, and instead of I squared, I can write negative 1. So that gives me 4 plus 9, which is 13.